let's finish off this section with looking at the other types of containers. So containers, or collections I would call them, are data structures which you can use to collect or store an amount of data, and you can update these structures, and you can add things to them, remove things from them, read from them, and so on. So it's a way to organize data in a program. So let's look at lists to begin with. So this is how you would create a list. You could either do it with the empty brackets like this, or you could use the list constructor like that. And let's append some stuff to this list, the first list. So a bunch of names, and appending means that you can add something to the end of a list. If we look at VS Code, and if you type dot, then you will get a quite good understanding of the different types of methods that you could use on a list. So you could append to a list to the end of a list. You could clear it. You could copy it. You could get the count of it, or meaning the length of it. You could get check if there's something at a certain index. Basically, which means that you can search in the list. You could pop, which means that you remove from the end of the list. You could remove any element inside of the list. You could reverse it. You could sort it, and so on. So it's quite good to understand what these do. I won't go into the details of each thing, but it's good to know. Let's print out each name of this list and see what we get. This will be interesting. So we get Bob, John, Sarah, and Tony, which is what I expected. So it's a nice thing to know that you could loop through this list, and you can add things to the list and remove and so on. So this is a really helpful data structure, the list data structure, which exists in many languages. Sometimes they're called an array, and sometimes they're called a list, and some programming languages differentiate between a list and an array. But in Python, list is usually what you would use to deal with data which has a certain order, right? And sometimes the order is not significant, but it is good to know that a list keeps track of an order, so you can get things at a certain if I print like list 1 at a 0 index, then I should get Bob, right? I won't do that now, because we see that when we iterate through this list, we get them. So we can safely assume that this is at the index 0, index 1, index 2, index 3, right? Let's continue to look at another method. So pop means that it removes and returns the item at the last index. And you could even specify what index, but usually when the pop method usually doesn't take any parameters, so it just returns. It removes the last item and returns it. So if I save this to a variable, I'll say last, and I call the pop method, and it will mutate this array, or this list. It will remove the last, so that will be Tony, and then it would save Tony here. So let's try to run this and see what happens. So if I run this again, we see that we only get Bob, John, and Sarah, so we don't get Tony. But this should keep track of Tony. So if I print Tony now, or if I print last, we should get Tony. Let's see. Yeah, we see that I get Tony at the end. Lots of names now. I hope that doesn't confuse you. Let me run this again just to prove the point. So we see that we get Tony at the end, and that is because I can maybe even print something like this, just to show you that the list no longer contains Tony, but we saved Tony in this variable. So let's see. Yeah, you see that the list no longer has Tony, but I saved it to this because pop returns the name, right? Let's continue to look at some other things. So let's look at remove. So remove means that you can remove something from a list, right? So we remove Sarah from this list. If I print it, the length should now be 2, since we removed Tony and now we removed Sarah as well, so it should be 2. Let's see. Yeah, and we see that it's 2, which is nice. Let's continue. So clear means that it clears the whole list, so there should be nothing left. So the length should now be 0. Let's run this again. Yes, and the length is now 0. So that's good to know that you can even clear the whole list. Let's look at another data structure. So let's look at sets. I would say that sets in some programming languages, they usually have they are usually known as sets or hash sets. And what they can do is that if you're interested in maybe not reading the actual value sometimes, but sometimes you just want to keep track of something that has happened, for example, and then you want to ask some source of truth, some data source. You want to ask it, does this exist at this point of time? And if you get it, you can either get a true or false. So you can ask the hash set in this case, does this value exist? And it will give you true or false, right? But sets in Python are a bit different. So sets in Python are usually used to kind of compare things, to check the differences between different sets. So you could have two data sets, and then you can use the set methods to check the differences. It could be, is there anything similar between the two sets? What are the differences between the two sets? What are the intersects? What are the things that exist in both sets, and so on? So I won't go into the details of what these different methods do, but let's just print out the difference here to see. So I checked set 1 and set 2, and I ask, so what is the difference between the values in set 1 and set 2, right? So what is different? So basically everything is different, right? But if I add red inside of here, let's see what happens then. Then we only get blue and green, because red is not something unique for this set. It exists in both, right? So you would only get blue and green. So that's good to understand. And finally, I would like to talk about tuples really quickly. And tuples are very similar to lists. The only difference is that you can't add anything to them or mutate them or change them in any way. So you can't add to them, you can't remove, you can't change values inside of it. It just keeps track of a set of data or some type of data. And you can unpack the data, you can read from the tuple and so on. So let's see what happens with, if I print A and I print B. Let's see, let me do this. Let me do this here, right? So we see that we get 1 and 2, right? If I say 3, what happens then? Yeah, so it basically gets 1. So this will be assigned to A and this will be assigned to B, right? Let's try to print A, B, and C at the bottom here to see what this will give us. I can remove this also, I think. So it will give me 3, 4, and 5, which is quite interesting. I'm sorry. So if I print this out, so A will be 1, right? Because it's equivalent to the first value, and B would give me the second value. And then if I use this asterisk, what it does is that it takes the rest. So 3, 4, and 5 will be a list of integers. So that's why we see that 3C is now a list of the integers that remain in this tuple. Thanks for watching this video about containers, and see you in the next one.